Good evening, everyone. Today I'll be talking about OpenStack. OpenStack is one of the bit older because it's been there in the market for quite a long time. And we've been using this to create the IaaS, that is nothing but infrastructure as a service. Either it is in the public clouds or private clouds or in our own local data centers or in our own the premises and other things which we can create. The OpenStack the infrastructure. So why do we require this OpenStack? There are many other people who are already been there in the market. VMware is, and in the public clouds, if you just see AWS, Azure, and Google Cloud, DigitalOcean, like many other clouds are there. Why should we go for the OpenStack? Because it is open. It is not actually going to cost you anything like that, and the software is completely free. This is open, so we can build our own stacks in our own premises with our own engineers. So if you have that skill set, we can start doing all these things and all because it's quite completely free. And so we are going to see in this a small presentation that why we are using this as OpenStack, why we are going for this, what is the pros and cons on this, what are the advantages, disadvantages like that, and what are the components in the OpenStack, how do we configure that, and which platforms it is going to get supported on that, how do we configure this one. And after this one, the small presentations, I'll be showing you. I install it in my Ubuntu local VMware as like a VMware workstation like that. In the VMware workstation, Ubuntu virtual machine is running Ubuntu 20 is running. In that one, I installed this OpenStack, and that has been completely perfectly working with it. But only problem is that I don't have much memory or CPU to allocate many things. So I'll be running on a very tiny nodes on that. Means like we can create the virtual machines inside, like how we are creating in AWS and other things. Instances which we are creating, and we log into there and we're running some services on this like that. So we can run everything on this. So it is nothing short of any public provider who is providing some network services, infrastructure services, database services, like other things which we can have, that IaaS can be perfectly running with the OpenStack. It's possible. Okay. So I'll be showing you the demo, and the dashboard has been there, beautiful. And we can able to see that one, like how many instances are currently running and what is the CPU utilization, memory utilization, volume utilizations, and other things. We can log into that nodes and we can find out that possible. So let's talk about that. What is OpenStack first of all? Maybe like 10 to 15 minutes I'll be running this slides. Then we'll go to the demo on that. Okay, next. What is OpenStack? Free and open source cloud computing software platform. Provides services for managing the cloud environment on the fly. Let me take the pen. Okay, so two things are there. And it consists of a group of interrelated projects that control the pools of processing, storage, and networking resources. Provides the methods, users, and support that deploy the virtual machines in a remote environment. State in OpenStack is maintained centrally managed by the relational database, that is a MySQL or MariaDB. Okay. And OpenStack provides all services in an IaaS. IaaS means infrastructure as a service. Everyone knows that because it's now we are all working on a cloud platform mostly. So we know everything on this. So a little bit of more explanations. OpenStack is a collection of open source software modules and tools that provides a framework to create and manage both public cloud and the private cloud infrastructure. You see that? Public as well as the private. We can construct it in both, because nowadays OpenStack has been supported by every other cloud provider. I can just say that because we can create an OpenStack for our own stack machines like that, and third-party integrations are also possible on this. And moreover, third-party providers are also there. Means like if you're looking for OpenStack infrastructure need to be created for your company, in the sense, they will help you in consulting all this. That is also been there. I'll show you some of the links on the left in the last slides or something. Okay. OpenStack delivers infrastructure as a service functionality. It pools, provisions, and manages large concentration of the compute, storage, and network resources. These resources, which include bare metal hardware, virtual machines, containers, or managed through the application programming interface. There is a API, definitely, as well as OpenStack dashboard. We can run it with the CLI API as well as the dashboard also we can manage it. Other OpenStack components provide orchestration, file management, services intended to support the reliable and high availability operations. Businesses and service providers can deploy the OpenStack on the premises in the data center to build the private cloud, and in the cloud enable the drive and public cloud platforms and the network edge for distributed computing systems. You see that every other interactions are possible, integrations are possible on this. So it is none other than the normal cloud which we are working on that, but this is going to be our own cloud we'll be building on our own. So from the coming up the next slides like that, we'll just see what is the infrastructure, what are the components are there, what component is doing which work, and who is going to store all these images and other things, how the networking is being done, where the machines are getting loaded, like what is the platform of the machines getting loaded, virtual machines. These are all we are going to see it on the next slides. OpenStack architecture. This is we will be seeing like this is the overall diagram about that, architecture. You see the Keystone. This is the identity service. Then you just say Nova, that is a compute node. Glance, it is an image service. Swift and Cinder, that is going to be the object as well as the volume. Okay, then Neutron providing the network. Simple. And to see everything like that, we will have a horizon dashboard. Horizon dashboard is there. So Keystone provide the identity service. Nova providing the compute nodes, creating the virtual machines. Glance is providing the images for the virtual machines. Swift and Cinder providing the volume service and object services. Neutron providing the network for it. So we will be seeing that some of the coming up slides are there. That will be giving you the much explanations about that. It's a modular architecture designed to easily scale out based on growing the set of core services like that. Okay. Let's go to the next one. Components. One by one, we will be seeing that. Keystone. What is a Keystone? Is an identity service. Keystone is an identity service, common authorization framework, managing the users, tenants, and roles. Where it is going to be, like the machines are located, project like that. And pluggable backends like SQL, PAM, LDAP, IDM, and other things. So we'll see something more explanations on the Keystone. If you're installing OpenStack manually, the first step is to get the service that can act as the guardian of all others. That is Keystone. Keystone performs the job of authenticating and authorizing the users into the OpenStack cloud. It also acts like a template for the services to advertise their endpoints. Project or tenant is a container of users and virtual resources. Tenants consist of VMs, networks, images, storage volumes, and users extra. User can have the specific role in a tenant. A project can have multiple users. A user can be part of multiple projects. Although the same user can have different roles in a different project as well. So this is going to be controlling everything on authorization, accounting, and all these things on the project wise. So all other services in the OpenStack depend on the Keystone for discovering each other. Public URL of the Keystone is the starting point of all operations in OpenStack. With an identity service in the place, we can now be thinking about putting up other fragments of the puzzle like that. So this is the Keystone. Keystone is nothing but this is what we see. Identity service, common authorization framework, managing the users, tenants, and roles, pluggable backends it is providing. The next one is about image service. That is a Glance. Glance image service stores and retrieves the disk images. You see that. And the virtual machine templates like that. It goes on. Supporting the raw, QCOW, VMDK, VHD, ISO, OVF, and AMI, AKI, everything, every other images has been supported on this. Backend storage is a file system, Swift, Gluester, and Amazon S3. Amazon S3 also we can use that. Okay. And then you'll see the next one. Glance. This is an explanation about the Glance. Probably the most commonly used virtual resource in the cloud as a virtual machine. Unlike their physical counterparts, virtual machines are almost always created from the templates. Glance is the image hosting service of an OpenStack cloud that we've seen already. Then glance can be configured to store and retrieve the images from the variety of the sources. In the most basic setup, the images are stored directly in the specified directory as files. Glance can also be configured to use an object store service, that is a Swift, or a block storage service that is called as a Cinder. Block storage in the sense it's nothing but an S3. It can even pull the images from the AWS S3 buckets. You see that? So that is about the glance. Okay. Next. Oh, sorry. In that one, we are going to see the Nova. What is Nova? Core component service comprised of, core component service is comprised of, it's a drawing, okay. And sorry, pen is not properly working. Okay, core comp is, it's comprised of compute nodes, hypervisors that run on virtual machines. Supports are hypervisors like a KVM, Zen, LXC, Hyper-V, and ESXi. Distributed controllers that handling the scheduling like the API calls and etc. Native OpenStack API and Amazon EC2 compatible API is that. So Nova is what? It's like a hypervisor is working on like that. Okay. Then we'll go to the next explanations about that. Nova is component responsible for providing the compute facilities in an OpenStack cloud. Nova is a collection of services that run across the multiple nodes. Controller node runs on the management part of Nova, while on the computer nodes, Nova interacts with the underlying hypervisor to manage the virtual machines. Like in our VMware environment, either VMware workstation is working on behalf of the host and guest like that. So that way we can see. The Nova metadata service provide mechanisms to store and retrieve the instance related metadata. The most common example of the metadata includes the key to enable the passwordless access for the user. When a machine boots up, a script contacts a metadata service to get this info like this. So these are all 3 points. When it is booting up, it will be looking for that information for that from the metadata. It will be retrieving all the information for us. Next. Compute service is the core compute facility that interacts with the hypervisors to create and terminate the instances. Nova conductor service act like an agent of the compute service. It takes up requests for spanning virtual machines, decides on which compute node in a general. There are more than one. The VM has been to be spawned. So it is like a hypervisor. It is working on the Nova services or like you can take it as next. Sorry. Networking, we are going to see that. Neutron is a very important service because without a network, we will not be able to access the service which is running on OpenStack cloud platform. We need to get an external IP. We need to get an internal IP. Otherwise, we may have to do some kind of a VPN configurations. We may have to run it from the remote places as well. So like Neutron is a service which has been giving the accessibility to the virtual machines which are created inside the OpenStack cloud. Network service provides a framework as a software-defined network. You see that? Very important point. Plugin architecture allows the integration of the hardware and the software-based network solutions. Open vSwitch, Cisco UCS, standard Linux bridge, Nircia NVP. These are all the things are actually being supported. It's a bit old, the slides are maybe like some other services also been supported. But normally we talk about the Open vSwitch. That is for OpenDL and other things are using on this. When we go for a virtual switch, open virtual switch like. Then is Cisco UCS, comprising the Nexus and other platforms. Standard Linux bridges, we normally do that. The Nircia NVP. So this is a network service. How the network service has been working on this is just a brief introduction about this. We will see something on network services. The most complex part of OpenStack lies beneath the stone titled networking. OpenStack provides 2 options for the same. Historically, Nova Network, a part of the compute component, was also tasked with doing the network a bit. It's a legacy component now, considering that the prominent reason is it exists. It's because these systems are out there still using it. Next. OpenStack offers a per tenant networking, just like any other common AWS provider. This means that we can group the resources inside a box, network them in a fashion with almost no constraints, and can choose exactly how the box interacts with the rest of the world. It's like a VLAN creation. Like here we can call it as like a VXLANs, but anyway, it's like a VLAN only. In short, every project or a tenant in OpenStack is a free to do custom networking without interfering with other projects. Completely, it's exactly the same VLAN. Within a VLAN, we can do anything. So people would like to come into the another VLAN in the sense they require some router or something. The same way, it's been done in a software fashion. So that's what they're talking. Next, this is how it's been all tenants. All tenants. So let me take the pen now. So here, you just see all the tenants in a private network possibly with the same subnets. 10.0.16, 10.0.16, 10.0.16. Then to access from the public network, tenants can add a router. This is a router has been added. It's talking to the public network on this. Right. Then it says the the VM can then be attached to the public IPs or the floating IPs on demand. We'll be allowing some kind of floating IPs and other things. So like an external IP, you can just say. So this is like an external IP has been assigned for this guy. So this router will be in a position to talk to the public network. Will make us a connectivity between that. So this is what has been done in the Neutron service. So internally, the people within a tenant or like a project, they can have their own IP addresses and other thing. There is no problems at all. To access the public network, we will be adding a router. This is a router we are adding here. And the router will be making the, project, every other project to talk to the outside. Like, so this is a project A is talking, project B will be talking, project C will be talking. So we'll be providing one router here, like this. Simple. It's like our VLAN and other things. Okay. So let's go to the next slide. Neutron uses several tools and plugins to do the complicated job it is assigned. One of the most common tool that you may come across while configuring the Neutron is Open vSwitch or OVS in short. OVS is a virtual multi-layered switch that creates a virtual networks through which the instance traffic has been passed through the tunnels like that. So how the operation has been taken part, like, so through the Open vSwitch, they will be talking to each other. It's like OVS. So it's a multi-layered switch, creates a virtual network through which the tunnels are created for that each and everything. The VLANs, VXLANs has been taken on that, and it's been going with that. Neutron is a complex component that may need a number of fine tweaks to work in your physical environment. We need to do a lot of work. In addition to the basic networking infrastructure, Neutron has also plugins for providing the services like DHCP, firewalling, even load balancing. So this is quite common because all the network components has to do all this work, normal work like firewalling, load balancing, IP address mapping, external, internals, VLAN creations, VPN creations, VXLAN creations. Everything has to be done by the network component. So that has been doing the router creations. Okay. Next one is in Horizon. Horizon is nothing but a dashboard. In the dashboard, we are going to see everything on a GUI. It's like a graphical user interface. We'll see the machines, virtual machines, volumes, and the networking topology and the components which are there inside, and how much database has been backed up or something like that. So we will be seeing like a dashboard, like everything will be showing like a dash dial. So it'll be showing, like it'll be how much memory has been utilized and how much CPU has been allocated, how much memory has been coming up on that. Network topology will be able to see the diagram, which router is connecting where like that. So provides a simple self-service UI for the end users. Basic cloud administrator functions define the users, tenants, and quotas, and no infrastructure management. Infrastructure management, no. Okay. So Horizon is OpenStack dashboard. You would have seen the dashboard of the AWS in the previous sessions. Means like core functionalities of the AWS dashboard can also be seen in the Horizon. Means we would have seen that AWS and all. So Horizon provides a user to GUI to create the users, tenants, networks, routers, and other thing. Most importantly, provides an easy interface to launch and terminate the instances. We can do everything we can do. Like how we are doing it in the CLI. See, in OpenStack, we can use the CLI also. There is nothing but API, we are going to do that. The way we are able to do it on the CLI with the commands on creating all these things. AWS has also got a CLI. It's called as the AWS CLI. And Azure has got something on some of the commands which can be run from the PowerShell. It's possible. Like GCP has got a CLI. Everyone has got a CLI. So the same way, OpenStack has also been having a CLI, that is an API, along with the dashboard. We can do everything on a dashboard. Is in the AWS dashboard. We can do very easy to management service like that we can do. So the same we can do it on the OpenStack also. Other features that Horizon provides include associating the floating IPs. That IP make a VM directly accessible to the outside world. That is nothing but an external IP we normally call. And creating and managing the security groups, rules to allow and disallow the network traffic. Like you can compare that AWS security group to allow, like accessing the servers inside. We will be providing the port numbers to open like SSH in case of Linux, RDP in case of Windows. When we are going to run the web server in the Linux instance or Windows instance, we'll be seeing HTTP port open. We'd like to ping it out in the sense we'll just say ICMP opening. Same way, we will do here also, like creating a security group, and we will be providing the external IP, that is nothing but a public IP assignment we can do. And keep in mind that the dashboard is only pulling strings behind the scenes using the individual APIs that all the OpenStack services expose. Yes, exactly. You see it in that means if it's a visualization format, so you're seeing it. But actually, it has been running on everything on a backend of the API only. Okay, that is about the Horizon. And the Swift, we will be seeing that Swift and Cinder, we will see both, like object storage service modeled after AWS in like S3 service, provides a simple service for storing and retrieving the arbitrary data, native API and S3 compatible API. So that is nothing but as Swift. It is nothing but creating like a bucket something. They just keep some data over there, dumping it. OpenStack has got two components to cater the storage needs for the user, Cinder and Swift. We can see both. Cinder is a block storage, and Swift is object storage for solutions as a OpenStack. Instances that are created by Nova are configured with a small amount of storage. Storage is released as soon as the instance is being deleted, means like terminated. That's very important. Cinder and Swift. One is for block storage, another one is for object storage. So simple, everything is like when you come through this kind of cloud environment, everywhere you'll be seeing kind of, storage service will be there. Instance services will be there. Database service will be there. Network service will be there. Right? These are all quite common in all the, because when you would like to run a network in a complete network in the sense, there will be a database, there will be server, there will be network, there will be people will be logging in. So we require an IAM like that, giving the authorization and accounting and other things. So it's quite common. So you'll see some next. So Cinder. Cinder is a block storage volume service, provides a block storage for virtual machines, persistent disks. Similar to the EBS services, Elastic Block Store, we normally say. Plugin architecture for the vendor extensions. Exact example like NetApp driver for the Cinder. So this is both are, like block storage as well as the file storage you can take this. If users wish to keep the data persistent, there are two ways to do. One is like a Cinder volume or attached to the VM. The VM can treat this volume as similar to the new hard drive or an NFS mounted file system, network file system that is actually it's used in the Unix systems actually. The volumes can be detached and then reattached later to the same VM or other VMs. So this is we normally do with this AWS things. Okay, next. So these are all things you just need to know. OpenStack services like which service is doing what. Keystone, we've already seen that. There are things like, it's like a recap, you can just see. Let me take the pen. Keystone is an identity service that is providing the user authentication, authorization, other things. Glance, storing the images to the boot the VMs. Nova, computing the capabilities, means hardware, software selections of the PC, the server. Neutron is providing the network architecture. Cinder is providing the block storage. Swift is providing the object storage. Silo metering services, we are not discussing this. Heat, orchestration templates. Horizon is a dashboard like this. So these are all where it has been run, which service is running in either it is a node or controller or somewhere. We'll be seeing it in the next slide. So service we seen that. What is the purpose of that service also we seen. Where it is actually the services are running, we'll see. Keystone is running on controller. Okay. Keystone is running on the controller. Glance is running on controller. Nova will be running on compute as well as in controller. Neutron, network, compute, and controller. Cinder, block storage and controller. Swift, object storage and controller. Ceilometer heat is not required. Horizon, that is running in a controller. So where it is, which service is running in which, like which identity, which entity it has been there. So we've seen that. These are all things which we discussed. The Keystone, Glance, Nova, Neutron, Cinder, Swift, then Horizon. So by making all these things, we'll be able to build our own cloud in our own environment. You don't require any AWS or you don't need to go for any paid services or something. We can create it in our own cloud. Okay, let me clear this. Let us go to the next slide. So what are the pros and cons of the OpenStack? So whatever the technology you're going to take that, there will be some advantages as well as the disadvantages will be there. There is no doubt about that. So we'll talk about the advantages first. It's affordable. OpenStack is available. OpenStack is available freely as open source software released under the Apache 2.0 license. This means there is no upfront cost to acquire and using the OpenStack. It's a free. Then reliable with almost a decade of the development and use, 10 years it has been there in the market. So OpenStack provides a comprehensive and proven production-ready modular platform upon which an enterprise can build and operate the private or public cloud. It's a rich set of capabilities, includes scalable storage, good performance, and high data security, and it enjoys a broad acceptance across the industries. Vendor neutral, this is a very important point. Because of OpenStack's open source nature, some organizations also see it as a way to avoid the vendor lock-in as an overall platform as well as the individual component functions. So these are all the advantages of using the OpenStack. What are the advantages? It's very much affordable because it is completely free. Coming with the open source license. Then reliable, scalable. You can do everything. Like vendor neutral. There is nothing like vendor lock-in something is there. So these are all the advantages. What is the disadvantage? We'll see. In the next slide. Complexity. Because of the size and scope, OpenStack requires IT staff with a significant knowledge to deploy the platform and make it to work. Definitely, we need to be proper trained because it is very hard to manage things if you don't know the technology. In some cases, an organization might require additional staff or consulting firm to deploy the OpenStack, which adds time and costs. Maybe like this is an initial cost. The return on investment can come later. Support. As an open source software, OpenStack is not owned or distributed, directed by any one vendor or a team. This makes it difficult to obtain a support for the technology beyond the open source community. So we need to depend only on the open source forum like that. But there are some people out there, like that's what I was saying, that there are some consulting team has been there. We can hire those people. They'll be providing you 24/7 support according to your SLA. But there is an extra cost actually. So anyway, you're not going to spend money on hardware, software, and other things and all, licensing things and all. It's completely free. Consistency. OpenStack component suite is always in a flux as new components are added and others are deprecated. This is available in everywhere. Like, this kind of consistency things, it's available in all the technology. 2 years back, what we use is not the same version we are using it. It's different versions are coming up. So added features has been coming up. So we will not be able to be escape from this. So what are the disadvantages as they are discussing is because complexity, you require the proper knowledge to work on this OpenStack cloud. Second, support is not available. We need to hire the team for the support. We need to pay extra. Then consistency. It's about the updates which are happening quickly. So these are all the pros and cons of the OpenStack. Let's go to the next slide. So these are all the links. anyway, we come to the conclusion of this. And this is a very small presentation which is made it that bit, but your OpenStack has got so much of things to get explained. This is an introduction. Okay, maybe you can take it as like a first, presentation on this one. So various distros of OpenStack. There are many kind of distributions of that. Like in Linux, we are having a lot of distributions like that. So OpenStack has also DevStack is Microstack is many other things on that. Various public clouds supporting the OpenStack. If you go to this link, you will find out that. Various private clouds supporting the OpenStack. OpenStack infrastructure providers and consulting. This was I was telling that. People will be supporting you like for managing things and all. Installing the single node OpenStack in Ubuntu canonical. I installed this one. Like I installed this just a single node OpenStack in Ubuntu. It is running perfectly. You'll be able to see that one. So these are all the links. Once you visit these links, you'll be able to see all these things. Okay. And that is the last slide. Okay. So you can call me, you can WhatsApp me on this one number, and you can watch this same video on a YouTube channel on Ramnath Keshav. You can say it to your friends, colleagues, and relatives and other people's. Okay. So before going further, I would like to show you some kind of the links. Would like to show you. It's here. OpenStack Marketplace. It's here. You see that. Distros and appliances. What are the distributions which are supported on the OpenStack like that? Debian, VMware, WinDriver, H3C, CT Cloud Platform, Inspur, DevStack, EasyStack, Fujitsu. So many are there. You just go to Sardina, Ubuntu, Verantis, Tencent Cloud, Dell is supporting that, Ericsson. Like that, so many people are, tested with the clouds and other things. So these are all the people who are going to, these are all some kind of distributions and like appliances as well. So in the public clouds, which are all the public clouds are supporting the OpenStack? We'll see that. Let me go down slowly. ElastiX, OpenStack, Cellura, Cleura, Infomaniac, Oroc, OHV Cloud, Virtuoso, VxHost Public Cloud, ShortTech, Open Telecom, so many other. Just say China, Business Services, Orange, Nipa Cloud, DevStack Development, any other. Like that, we will be able to see the consulting people like that. Let's see. Hosted, Infra Solutions and Consulting. We'll see this one. This is quite interesting for us because from here we can get the support of the people from the components soft cloud consulting. 25 years of experience of these people like Mission Control. OpenStack Consulting and Integrations. In Asia, they are in NEC Cloud Systems, Cleura, VxHost, AW Cloud, not AWS Cloud, okay? CDAC. CDAC is providing in India. And Ubuntu, it's also been the cloud build like that. 99 Cloud Consulting. These are all the consulting companies we can go for the OpenStack support. Red Hat is giving that. Red Hat, we can implement that, like any distributions of Linux, we can implement the OpenStack, it's possible. So Red Hat has got its own OpenStack implementations now. So these are all the links which you can go through there. It's there in the slides, so you can go through that slides as well. So now what I do, I will be showing you, one second. I'll be showing you this screen. This is the one which I logged into the, Ubuntu Microstack. It's called the Microstack in the Ubuntu platform. Okay. So I just already created one server like Microstack launch Cirrus. Cirrus is the image file. The name of the server is a test. Microstack, every command has to start with the Microstack launching and Cirrus. Like if you like to see the server list, let me get the previous commands as well. We can check what are the server list on this. Microstack.openstack server list -f.json. It will be showing in the JSON format what all the servers are currently running on the OpenStack in my Ubuntu. Let's see. Taking time. Yeah, there are two servers running. One is test, which has been created from the CLI. That's a CLI API. Another one has been created from the the GUI only. I'll be showing you that. So in this one, we have the network. You see, from that one, I just see status is alive, active, network test. And this is the public IP like that. Image is zeros and the flavor is M1 tiny. That is nothing but a machine specification. We see normally EC2 instances, the T2 micro, T3 micro, something like that. We just see like the same way we have M1 tiny because I couldn't go beyond this because I'm having some kind of CPU limitations because it's running in a Windows again. So means like Windows is a host OS, Ubuntu is a guest OS. So when you like to install this Microstack on Ubuntu 20, this is Ubuntu 20. Okay, let me show you that. It's Ubuntu 20.04. You can install that. There is a Microstack things has been there. Let me show you that. How do you install this? And this link, if you go for this, edge computing like that, we can install it like this. It's very easy. Single node installations. Go to this link, it will be giving you all. So you just need to run this command sudo snap install Microstack beta. It's a beta version we are using that. Then you can just check the Microstack snap list and initialization. You just run this command Microstack init auto control. Then it will be starting there. It will be taking at least 20 minutes for you to start entire things. You need to wait for that. Then later I can just see what all the image list is. I can run all the commands as well. So it's going to be running the things in the backend and it will be giving you the reports about the flavors list. Means what all the servers are there. Infrastructure, M1 tiny, how much RAM is required, disk is required, like this. You can even run this command here. It's possible. Let me run this command. Take some time to give me the output. It's a same thing. It's a M1 tiny, it's a 512 MB RAM, one disk, ephemeral is 0, vCPU is a 1. It's public, yeah, it's true. Like M1 small, medium, large, extra large, and other things. So see, extra large we require 16 GB. I don't have it. So we will be always running this because we just need to do some kind of demos like that. Just need to know how to create a thing on the things. So let me go back. So creating an instance like that, we will just say Microstack launch. Cyrus is the image name and test is the name of the server like that. So once it has been launched, it will be giving you this kind of server test is been launched. Then you can able to access it with this. It's like that it will be giving us. SSH we can do on this. Access the cloud dashboard, we can get it on the dashboard as well. So if you like to log into that server which has been created, so this is the command we just need to run. Just copy this one. Okay. Let me log into my server once more from another terminal. Then I'll be running this command here. Okay. I don't want to mess it up over there. Just say yes. It's asking about the key for the SSH and I say yes. So now I logged into the server which I created in the OpenStack. That's a Linux server. It's a uname. If I type uname, it's a Linux. Okay. Cat etc os release. It's saying build root. Version is this. Version ID, pretty name, something like that it has been giving. I can run all the normal commands on the Linux. It's a Linux box. So date, calendar, who am I, who, like that it will be coming. Zeros is the name of the person who logged in like that. So it's like that. It's a quite normal thing. Like if you do not want, you can just say exit. You can come out of this like this. So this is for SSH logins. And let me go to the dashboard. That will be quite interesting for you all. Okay. Logged in. So this is what the project has been. Let me make it bigger. Now you can see it here, like OpenStack. I logged in as with the IP. The IP will be always given the dashboard IP. And we need to try the password. There is a command for to get the password as well. So this is now it is saying that 2 instances are there. I can create 10. vCPU is 2, 20. User is 1 GB because 2 servers are running on this. Volumes, it's not been used. And the network, you see that floating IP allocated 7, used is 1. Security group rules are there. Networks are 2, ports are 13, routers are 1, like that. So usage summary, you can just see here. There are two servers currently running, test and test 2. Virtual CPUs are 1. Disk is 1 GB allocated. RAM is 512 MB, 6 minutes it is running. If I go back to the instances, you can just see that. What are the instances? Oh, like it's been logged out. That's why. Let me sign in. Takes time. Now it's came. So there are two servers currently running. One is a test 2, another one is a test. You see that. There's a server which I created from the the CLI. This I created from the GUI. And it's saying that keeper, Microstack keeper, and the state is active. Availability zone is a Nova. And power state is running. And here also you can just see this is the IPs which are assigned for this, external and internal IPs. Exactly like our EC2 dashboard, you can just see in AWS like that, the same way. It's very easy for us to create one more machine here. Let me try that, okay? Let me clear this. Let me close this. And before that, I would like to show you the, let me go to the test 2. If I click there, I can see all the informations about the server. Details. Actually, interfaces, console. Let's see the overview. Test 2 description and other things are there. I can just see all. External IP and IP and other things that what are the security groups this has been given on. These are all given. So interfaces are, it'll be coming up. They're very bit slow because it doesn't have much memory or CPU for that. So it takes its own time. So these are the two interfaces, external IP and internal IP. Log, you can just see. Installation logs or action logs, you can see that. See, so there is root FS, keys and other things it's showing. So there is OS. Console. From here also we can pick up the console. It's coming. Yeah, let's come. So CIRROS, that is a username. Password has been the default password, GOCUBSGO. Just like that. Okay. Uname -A. I give that all information will be Linux text 2. 4.4 is a kernel. Ubuntu, this is a Ubuntu flavor like that. You can just see when it has been June 24th, I think it's been created. You can just say date and cat, EDC, OS, release, shows that everything. So if you want to go back and just click back, that's it. It goes off. Action log, it's here. Takes time. You need to be patient. Okay. If you have a good system, if you have enough memory and other things and all, you can even like run it in a remote system like that. Good infrastructure server. If you run it, you can do some kind of remote access as well. It's possible. So like this is the overview. We see in the test 2 server. So this is what it's been showing the dashboards like this. We can create the server from here. Let me try one more server creation through the dashboard. Let's see. If you're lucky enough, we can able to see that the creations should be working because the only thing is that the infrastructure issue. Launch instance. Let me see. I'll be giving the test like test 3. I'll give it. Availability zone has been selected. So it is having the 3. Total instance is totally 3. So let's say next. So I have to say select boot source. Don't want to create any volumes as well. I'll be picking up this, like available one, I'll be picking up. So it is a Cyrus allocated boot resource. It's a kubectl2 model, like means we normally say ISO and other things. In Linux, we will say kubectl2. So which server we would like to install it means in the sense what kind of hardware. So I'll take 1 GB only, this one, M1 tiny. Select it, it's a allocate. Then just go down. Next. Subnets, we just need to provide both internal and external. So it's already saying launch instance. Let me go to the other steps as well. And network ports, we don't require because we are going to give only the default things and other things. Security group, it is already the default ports are available, already given on this. Key pair, let me choose the Microstack, which I created one OpenStack like that. Microstack is automatically created one. We will use that. Then the next, it's like if you like to run any script before the server is starting like that. It's like a schedulers like that. Normally we say cron jam or something. So we don't require this here. We don't go in for a very higher configurations or something. Server groups I'm not creating. And scheduler hints alone, I'm not doing anything as such. And metadata, I'm not giving anything at all. I'll just say click launch instance. Let's see whether it is creating. Scheduled creation of one instance. It's coming up. Automatically it will come up in the screen. Test 3 is the name I just given. Yeah, it's coming up. So it's building. Now it is building. These two are active. This is building now. Spawning. Associate the floating IP. It's been already given on that. Should be coming as like an active. Then we can able to see what's actually happening on this. We can able to log into that. It's still building. Say it's saying active. You see that? It's saying active now. Like the other things, active, active, active. There are 3 servers currently running on my OpenStack. Internal OpenStack, I'm just running on my own cloud. It's been running on that. Let me go to this guy, test 3. It's taking time. It's come up. So this is a test 3, status is active. It's not locked, availability zone is a NOVA. By default, it has been taken. M1 tiny, 512 MB, 1 CPU, 1 GB hard disk. There are 2 IPs are assigned. Right, we'll go to the console. Let's see if I can fire up the console. Loading, loading, loading. Let me click. Coming up. Yeah, it's ready. But it'll take time. Yeah, it's coming. CRROS. Goku BSGO. What a password. Okay, so uname -a, which are in the Linux and everything. So it's simple, exactly the same, like the one I am using that. So it's showing the same thing. Let me go back to the instances. It'll show me all the 3 instances as well in the list. How we are creating the EC2 dashboard, like all the series of servers will be shown over there. You can log into that, you can do RDP, you can do SSH like that. I mean, go to the network and I can see the topology. How the servers are connected, like the topology diagram will be shown here. Loading, loading, loading. Because of the, see that there are 3 things are there, and you can just see there are 3 servers are there. Test 1, 2, another thing. This is an external network which is connected on this. All the 3 people are connected on this. This is like a wall symbol has been there. It means it's an outside network like. And this is a test. There are 2 networks. One is an internal network, which we have 192.168 something. The external network, the IP which has been already chosen like a 10, 20, 20. This is not hosted in the outside, like it's been hosted in my own single node infrastructure, which is taken on that. So if you like to say the floating IPs, you can see that here. Floating IP is nothing but an external IP. These many IPs are, associated with that. Once we are disabling the server or terminating the server, in the sense, come back and do all the cleaning of things. Otherwise, the IPs will not be available on that. Okay. So this is about the servers and creations and OpenStack and other thing. Dashboard is so beautiful, right? You can go back to this compute and you can see the overview. Got it? Takes its own time. So 3 used is 3 out of 10. And vCPU is 3. And 1.5 GB because there are 3 servers running on that. So this is about our OpenStack. Okay. Let me go back to the last slide so that you can able to see my name and other things. So you can call me or WhatsApp me on this number. You can email it to me on this tuckedout@gmail.com. And you can watch this video in just next half an hour on the YouTube. And you can ping me on Skype as well. Thanks for joining. And subscribe to my channel if you're not already subscribed. And recommend my channel to your friends. Okay. Thank you very much. Let's see by next week with some new video on that. Thank you very much. Bye all.